All right, let's have a look. So let's say we've got our equation here, n equals p plus ae to the power of k times t. And the question we're saying is we wanted to show if the other one was a differential. So what we need to do is we are going to find the derivative of n. So let's do dn dt. Now p is a constant, so that's going to go away. We're going to be, because this is a nice exponential, we know that our derivative of that is going to be ae to the kt multiplied by the derivative of the power. Well, the derivative of kt is just going to be k, so we're going to put a k out the front, and it's k lots of all of that. Now, it says that the one that we wanted to prove was n equals 125 plus ae to the kt. So because it says we want to prove this one, the important piece of information is 125. So what we've got here inside my bracket is k lots of ae to the kt. Now, because we want to prove that 125 works, we're going to add 125. But if I'm adding 125, I've just changed my equation that no longer balances. So if I'm adding 125, I also have to take away 125, right? Because now that equation balances, because those two 125s will cancel each other out. I've picked 125 purely because that's the one it wants us to prove. If it had said 300, then we would have gone add 300 minus 300. So we've put in that. So what does that look like? Well, this looks like k outside of 125 plus a, that's a plus, ae to the kt minus 125. All right, so all I've done is I've just rearranged it. Well, look, this 125 plus ae to the kt is what we've got here at the front. So if I just scroll down a little bit, I can replace all of that then with n minus 125. And remember the rule that said if we had dn dt is equal to k lots of n minus p was our rule. Well, that's what we've got. Remember, we started with n is equal to p plus ae kt. So p is our 125, which is what we've got there. So therefore, we can say n equals, that's an n, 125 plus ae to the kt is a differential of our original equation, n equals p plus, so p, ae to the kt. Right? That's one possible solution. Right? Because that 125 is a constant, there are numerous other possible numbers that we could substitute in for p. All right, because that's what we're saying now, is that this 125 is our value for p. Right, like I said, there are going to be numerous possible differential equations of that n equals p plus ae kt, depending on what value we want p to be.